the whole story there is indeed, I would say, half-truth that you're hearing. There is no doubt that if we humans emit this carbon dioxide, some of it will stay in the atmosphere, of course, but we know also quite a lot of it actually will go into the ocean. And then once it goes into the ocean, of course, because this carbon dioxide will change the natural cycling of what they call the carbonate and the bicarbonate cycles in the biogeochemical changes in the ocean, that you will change the pH of the ocean, which is a measure of the acidity of the ocean.
Correct.
And there is no doubt that when you do that, you will actually make the ocean more acidic. There is also no doubt about that. The question then is that what does it do to the system?
Well, wait. Before we get to the question of what it does to the system, I have one other question for you regarding the ocean and the acidity of the ocean, because could it also be true that the hundreds and thousands of underwater volcanoes, because volcanism impacts climate too, could they acidify the ocean?
Oh, sure thing, of course. I mean, this is why actually if you talk about, as we all know that basically 50% of the volume of the ocean is below 2,000 to 3,000 meters, right? So we have only very little amount of water actually at the surface, and the bottom part is no doubt highly complex, but we also know as a fact that those bottom waters are extremely acidic, by the way. So this is why not many shell life could be sustained there if the water is extremely deep. And this is why it's a puzzle. The question, again, let's go back to the question of when you changes the acidity of the ocean, what will the ocean respond? How does it respond? The typical way in which I would say the alarmist or the scary story coming out from even scientists themselves was to say that, well, this is going to kill all the marine life. Essentially, the idea is that then you make the ocean more acidic, then the calcium carbonate would not be able to form. So that calcium carbonate we know is the material that is essentially chalk, right? That's making up the shells, bodies, and everything, right? And if you don't have that, of course, the marine life will be harmed. But I guess the surprising fact that has been learned actually as recent as only result that came out last year or so is that instead of making the shell thinner and weak and, of course, total destruction, the shell would grow better. This is a total shocking result that just came out actually about a year or so. And the reason why that you have such a strong contradictory result is because in the old experiment that we have heard of, all this old experiment that's been talking about, how if you change the acidity of the ocean, you will make the shell form less, is because instead of doing the proper experiment, by letting the carbon dioxide in the air and then bubble through the whole system, those people have cheated in their experiment. They have essentially just add weak hydrochloric acid to the water directly itself to study the response of the marine system, which is really a shock, a total shock actually. And in fact, the authors that produced this paper are immediately being treated as somebody that is extremely bad by even coming out with such a brilliant, I think, scientific results that, of course, that can be repeated by anyone who's studying them carefully. And the whole idea there is, of course, that don't forget that CO2 is also what I call food for marine life. Okay, we know that CO2 is food for plant life. There's no doubt about that. But CO2 is also food for marine life. There's no doubt about it, because the plants are essentially, because of the ocean, because of the buffer, the layers, the processes, the biogeochemical cycling in the ocean that actually sort of prevented them from taking in more of this carbon, they really, really love carbon. They are actually starving from not having enough carbon. And this is why this contradictory result could come out in so late in the game, because imagine everybody is rushing now in December to try to go to this city called Copenhagen to try to sign the treaty to control the carbon dioxide emission from every industrial use of all the good stuff that we use, right, the fossil fuel. And then all of a sudden you have such a result that shows such a directly opposite results. And it's very, very scary actually to think about how actually science is actually being second, I guess, being treated as a secondary subject instead of the primary subject that should inform all these public policies and all these governments and all these lawmakers. Well, they're not getting the right information. That's the point.
Could you stand by for one moment? We actually have David Legates on from the University of Delaware, who's a climatologist with a specialty in climatology related to water. But there's a way that you say it, David. Tell us about yourself.
Thank you for inviting me. I'm a hydroclimatologist, and so I'm really interested in the water cycle, particularly how it relates to evaporation and precipitation and how essentially changing environments change water distributions, particularly on the planet.
We will come back to you, Willie. We have not left the subject. The question then is, what is this thing about rising sea levels? Are the sea levels rising? What does that have to do with? There's all these elements on the wheel of the subject. What is this about rising sea levels, and where does it come from?
Well, sea level rise occurs from a number of processes. I mean, historically, if we look at it, sea level was very low at the end of the last ice age and has since increased as the ice has melted. Now, sea level rises for two reasons. One is the thermal expansion of seawater. That is, as seawater warms, it expands. And so with a warmer climate, as we've had over the last 12 to 20,000 years, the sea level that we've had has expanded in size and therefore has risen that direct dimension. And the second part of it is with the melting of various ice. So as we had a lot of ice stored on the surface in glaciers and in ice caps and things like that, we stored a lot of water that way, which was out of the oceans. Now with the melt that took place with the end of the last glacial period, all that water winds up in the oceans, and so we've seen a long-term rise in sea level. Now, that rise in sea level has been continuing, as I said, for about 20,000 years or so due to the end of the last ice age. So we've seen rising sea levels take place as a direct result of a warmer climate that isn't necessarily a warmer climate due to human actions.
I have a question related to that. In my last interview with Bob Felix, he said that, and it was verified, that glaciers are actually growing, that the very opposite of what we're being told is true, that they're growing. So if there's many, many more thousands of glaciers, mammoth glaciers that are growing, could that contribute to the sea rising in some way, or no?
Well, no. Essentially, there are glaciers that are growing. There are glaciers that are depleting. The glacier dynamics is really complicated. It's not just simply one of temperature rises, therefore snow melts and ice melts, and hence you get runoff into the oceans. Glacial dynamics is really a combination of factors between changes in temperature and changes in precipitation. In a sense, you can get a depleting snowpack simply because temperature remains constant, but the actual snowfall decreases. That's exactly what's happening in Mount Kilimanjaro. There's been a lot of airplay on the fact that the snows of Kilimanjaro are disappearing, and when you actually look at the temperatures of the peak of Mount Kilimanjaro, you see there's virtually no change in temperature whatsoever at that location. What's really happening is we've seen a shift from what was once a wetter climate that produced more snowfall to now a drier climate in that region, which actually produces less snowfall. So glacier dynamics are a lot more complicated, and as a result, sea level dynamics are a lot more complicated than just simply saying temperature rises, therefore glaciers disappear and sea levels rise.
Gotcha. It's a much more complex system. So where does CO2 and carbon get to be the main focus of the whole dynamic and the basis for new international law?
You know, Kim, can I jump in here?
Please.
This is Willie Soon.
Yes.
I think we should just get back to at least the basic questions that we find it surprising in terms of the level of scientific understandings in our world. It is somewhat surprising, actually. I didn't even dare to ask this kind of question maybe 10 years ago, but I do ask that very frequently these days during my talks and all these places. I started to ask people, how many people know that how many % do we have carbon dioxide in the air today?
That's a great question.
Yes. Do you care to answer that?
I certainly wouldn't know, even though my last name is Greenhouse. Don't assume that I know.
I see. So maybe we'll just cut to the chase by giving the answer away. Well, essentially that it was very surprising. Even some very, very smart people will answer something like, hey, about a few percent, things like that. But of course, that's completely wrong. We know that because the number is actually 0.039 or 4%, 0.04%. That